All right, dude, we are live. What's up, guys? This is Dem Keys, and today, today we're gonna be taking a short detour. But, dude, I'm gonna try my best for this to be a really short detour, so we can get back to doing Matplotlib. There you go, Matplotlib. Okay, no, like the detour is already distracting me. I'm gonna try and keep the detour short so we can get back to PyTorch as soon as possible. And dude, okay, so today I managed to start the stream a little earlier compared to yesterday, so hopefully we should be able to stream for at least an hour, if not a little longer, and that's kind of what I wanted to do. So that's that's awesome. That's great. And the streak continues. We are doing, I don't know, now our seventh talking stream in a row, or maybe eighth. I don't remember, but yeah, that's pretty awesome. I'm glad that I streamed yesterday as well. Um, even though it was only for like I think half an hour or 45 minutes. I think it might have been half an hour, but I was like, you know what? No, I wanna try and stream even if it ends up being only for half an hour. I wanna try and stream. I woke up like maybe 15 minutes ago, and then I had to rush to freshen up and grab my energy drink and make sure, I drink some water, and then, I can start streaming. Um, what was I saying? Yeah. Okay. So today we are going to be taking a slight detour. And the reason is because, well, fortunately, the reason is related to deep learning and neural networks and stuff. Because, okay, I was mentioning in one of my previous streams that I want to be able to visualize various things about neural networks. I want to be able to visualize their training and their loss, and also visualize their the patterns that they're learning, just so I can compare what what the learning process is like when there's certain types of data used for training and certain types of parameters versus when there's certain other types of data used and certain other parameters. Basically, just comparisons of different types of training, and comparison of the different ways that the models are performing. There's a whole lot of visualizations that I want to do, and I didn't want them to all be limited to just static images. I wanted some of them um, to be animated as well, if possible. And the two plotting libraries, or visualization libraries that I currently know about are Matplotlib and Seaborn, which is built on top of Matplotlib, or rather, it provides higher level functions that end up using Matplotlib. I believe they over time they kind of um, built separate tech as well that probably doesn't use Matplotlib. I haven't explored that part of it yet, but I believe there was a thing. I was reading a thing there where um, yeah, I don't remember. I don't want to give information without knowing, but at some point we're gonna explore Seaborn further as well, because I haven't had the chance to explore it. Um, well, I haven't had the chance to explore it as much as I would like to. Um, dude, we haven't been doing a whole lot of like data science. I mean, okay, we've been doing deep learning stuff, but like I just realized that I haven't been doing a whole lot of I haven't touched a whole lot of like the data science related topics. I haven't explored it nearly as much as I would have wanted. But the good news is, while I haven't been doing that, I have been focusing on deep learning. So I'm not complaining. Okay, so for today's stream, we are going to be focusing on animation in Matplotlib. We're going to be learning how to make animated graphs and animated plots. And I also want to explore what the limits are. Dude, I don't like this kind of layout. And this isn't the only website that I've seen this issue in. The TwitchLib website had this issue as well. It's whatever whatever, I don't know, template or layout or thing that they're using for the website. When you zoom in, it starts to become, hold on. When you zoom in, it starts to you do you see this portion? It starts to expand it so much that it starts to hide the data, and then you have to zoom in extra uh, to the point that it kind of collapses this, and then the entire theme becomes like responsive. It becomes like the mobile version, and then you're able to read it. But then you have to like zoom in too much. Fortunately, on this screen, um, because the screen is further away from me, zooming in this much, it is kind of necessary. It does help me with reading the stuff. So I'm not gonna complain too much, but like, dude, these kinds of layouts sometimes they annoy me. Which, I mean, look, to be fair, these layouts are built keeping various screen sizes in mind, and also various devices in mind, like various platforms in mind. I'm watching this from a computer, but there have been plenty of times where I've visited the website from a phone. Some people might be visiting it from a tablet, and each of these devices is going to have different screen sizes, right? And even if it's not a separate device, even if it's not a separate kind of device, like let's say there's 10 different people visiting the website from PC or even their laptop, each of these people, their screen sizes might be different, right? So a lot of times these themes, these layouts, they have to be, how do I say this? Their values have to be fine tuned to kind of fit well on all of them. And trying to make a one size fits all solution, it it's gonna sometimes fail. That being said, on one of my other screens, or rather, I had to zoom in a little too much. Um, let me hold on. Let me open up that other screen, because yeah, yeah. On the other screen, I had to zoom in a little too much, which was, to be fair, it was around the same as this, but that screen I believe is lower resolution than this. I believe that screen might be a max of 1366 by 768. I forgot what the resolution thing is, but yeah, that might be 1366 by 768. Um, and this one is 1920 by 1080. Okay, anyways, enough yapping about other stuff. Let's get into animations using Matplotlib. So, based on its plotting functionality, Matplotlib also provides an interface. Actually, hold on. I'm gonna interrupt myself again because this is not the documentation I was reading, was it? I don't think this was the doc. Oh, you know what? This might have been. Yeah, this might have been the. Is there like an animated bar graph down here? No, there isn't. Well, okay, there's here. Artist animations can be used to generate so and so. Yeah, I think this might be a different page. Give me a second. Let me just read this because I was where is that? Animations using Matplotlib. Okay. No, okay. So, um, earlier, before I fell asleep, I was reading this animation thing, and I remember reading some different text, not not necessarily this text, because there was something mentioned about um how anytime you try to draw something, there's multiple artists involved, and yeah, I know about that. Like there's like the different things that get drawn on the screen. Usually, each of them is a different artist, and so if you want to animate any of them or you want to customize any of them, you have to kind of access that specific artist and then change values around here and there, and that customizes the look of it. Um, and then I think that group I think that the group of artists also gets grouped into something called one artist, or I think that's called a container. Um, but I was reading something prior to falling asleep. Just a second. Visualization. Okay, okay. Where was it, dude? Okay. I'm kind of confused because now suddenly I'm not able to find that information that was supposedly on this exact same page. Um, okay. Anyways, we'll carry on. Wait, no, hold up. Matplotlib animations using Matplotlib. Um, animation example, animation function. Okay, we'll open up this animation example as well. I don't think this is the one. Um, let's open up this as well, I guess. This is the old version. Okay, hold on. Yeah, never mind. Okay. Um, all right. This is giving some information that I feel like might be helpful, but yeah, I feel like okay. Yeah, let's just read this. Okay, so animations using Matplotlib. Based on its plotting functionality, Matplotlib also provides an interface to generate animations using the animation module. An animation is a sequence of frames where each frame corresponds to a plot on a figure. Each frame corresponds to a plot on a figure. Okay, this tutorial covers a general guideline on how to create such animations and the different options available. More information is available in the API description in animation, which I believe is what I was trying to open previously. Uh, wait, no, I did open it. Okay. All right. So, we need pyplot, we need numpy, and we need matplotlib animation. So let's do that. Let me refresh this notebook. I actually, I don't know if the animation plays out in Jupyter notebooks. Let me just Google that real quick while this page loads. Matplotlib animation Jupyter. Inline animations. A solution is to use the notebook backend, which is fully compatible with Funk animation as it renders the Matplotlib figure itself. Okay, it seems like people do seem to be having an issue. Notebook backend. Inline means that the plots are shown as PNG graphics. Those PNGs cannot be animated. While in principle, one could build an animation by successively replacing the PNG images, this is probably undesired. A solution is to use the notebook backend, which is fully compatible with Funk animation as it renders the Matplotlib figure itself. And then there's something called JS. There's something called JS animation from Matplotlib. No, from Matplotlib 2.1 on, we can create an animation using JavaScript. This is similar to so-and-so solution, except it does not require any video codecs. Okay, you know what? We're gonna try this. We're gonna test out the code and see if there is a need for that. Okay, import matplotlib dot animation as anim. Okay, so we're gonna run this, and while this is running, we're gonna go to the bottom and create a new code cell. Give me a second. Where's the option for new cell? Because like these cells or these notebooks, they have this issue where the first time that you load them, there's not going to be an option for the cells. So I have to do something like, select one of these cells and hit A, and then that's going to create a cell up here, and then I can either delete the cell or I can move the cell down, and then the code and markdown options appear. Okay, anyway, so the thing has started. Let's go back to reading this. Okay, animation classes. The animation process, the animation process in Matplotlib can be thought of in two different ways. Func animation, which generates data for the first frame, and then no, wait, Func animation. Generate data for the first frame and then modify this data in each frame to create an animated plot. Okay. And then artist animation, generate a list of iterable, no, generate a list, which is an iterable of artists that will draw in each frame of the animation. Okay, so whatever it is that I had read earlier, it was this. It was artist animation. It wasn't Func animation. Okay, it also mentions Func animation is more efficient in terms of speed and memory as it draws an artist once and then modifies it. Yeah, that makes sense because you're not drawing like multiple frames. You're just drawing that one thing and then you're modifying the artist like you would manually. On the other hand, artist animation is flexible as it allows any iterable of artists to be animated in any sequence. That is true as well. That is true as well. If it's not enforcing like uh, any rules that if it's not enforcing any rules that um, you have to do like similar frames, then people can add in multiple different types of frames and make it like a slideshow of different graphs and stuff like that. But in my case, I think Func animation would get the job done. Now, why is it that I was reading this? To update the plot, you would need to. Okay, let me just read artist animation because I believe this is the code that I'd read earlier. Um, and this was okay. So maybe I accidentally skipped funk animation and directly jumped down to artist animation, or it could be that. Give me a second. Let me open up that page again on my thing. Okay. Another possibility is that I loaded the thing off of Google, and on Google, it might have been linking to this section of the page. Because, like, if I click on this, then this has like a specific link, right? So maybe this link is what was shown on Google. And so when I clicked it, it loaded up the web page, but it immediately skipped down to this section because that's what I was trying to load. And that's probably why I thought that that was the beginning of the page. Okay, anyways, right. So let's start with Funk animation. Uh, the Funk animation class allows us to create an animation by passing a function that iteratively modifies the data of a plot. This is achieved by using the setter methods on various artists, like Line 2D or Path Collection or whatever. Okay, so these are the things that get drawn when you call one of, or these are the things that actually control the drawing of various elements when you call something like the bar function or the plot function. I believe plot is for a line graph. I think so. Yeah. Plot is for a line graph, and that's where you see line 2D. I forgot what path collection is. I think path collection is just sorry. I think path collection is it's a isn't it a collection of line 2Ds? Or maybe it's used in multiple different ways. I'm not sure. Where was hold on. Wait, let's refresh this because I seem to have landed on I seem to have landed in like the middle of a page. Hold on. Let me load the thing again. Okay. All right. There. A collection of path as created by scatter. Oh, okay. So line 2D is for well plot for a line graph, and a path collection is for a scatter graph. Okay, all right. I was just curious. Maybe it could be. It could also be that it might be used for other things, or maybe for the other things there's like separate types of artists. The way for line graph there's line 2D. I'm not sure. I was just trying to make sure whether it's used for one thing or if it's used for multiple things. But it turns out it's only used for scatter plot. There's also something at the top that I want to look this diagram. I want to look at this diagram. Hold, oh God, this is a very long page. Okay, classes for the efficient drawing of. Oh, this is the matplotlib.collections namespace. Okay, these are classes for the efficient drawing of large collections of objects that share most properties. Example, a large number of line segments or polygons. The classes are not meant to be as flexible as their single element counterparts. Example, you may not be able to select all line styles, but they are meant to be fast for common use cases. Example, a large set of solid line segments. Okay, all right. Okay, let's carry on with this. So, a usual Funk animation object takes a figure that we want to animate and a function, Funk, that modifies the data plotted on the figure. Okay, that's good. So you just pass in the figure, and then the function, like within the function, it's gonna do the rest. Though, I mean, we have to write the function, right? Okay, it uses the frames parameter to determine the length of the animation. The interval parameter is used to determine time in milliseconds between drawing of two frames. Okay, all right, that makes sense. Animating using Func animation typically requires these steps. Plot the initial figure as you would in a static plot. Save all the created artists, which are returned by the plot functions in variables so that, wait, save all the created artists, which are returned by the plot functions. Oh, yeah, okay, okay. So um, instead of just like, axes dot plot, you would do, let's say, a equals axes dot plot or ax dot plot, and then whatever is returned by plot, you kind of save all of those things because those are the artists. And if you want to control what is being drawn in the graph, then you have to change the properties of those artists. Okay, which is returned by the plot functions in variables so that you can access and modify them later in the animation function. Okay, then you create the animation function that updates the artist for a given frame. Typically, this calls set methods of the artists. Okay, create a function, create a function animation, passing the figure and the animation function. Save or show the animation. Dude, I wonder if I save it, is there a way to save it as like a GIF? Or is there some other way that it would be? Also, this is interesting. I didn't know that it had these multiple different ways to show the animation. So we should test out each of these and see which one works best in a notebook, in a Jupyter notebook. I also need to see to what extent Kaggle notebooks support animated plots. Hopefully they do support animated plots. Okay. Um, Save or show the animation using one of the following methods. You know what? Even if it doesn't support, I wonder if, like, okay, let's say it doesn't support. Okay, that's unfortunate. If it doesn't support, maybe I could use one of these other methods in some other way. Like, I don't know, one idea that comes to mind, which I have no idea if it actually works or not, is embedding the animation. That's assuming the animation is in the form of a GIF or something. It's embedding the animation into uh, let's say Markdown or whatever other method. Okay, hold on. We seem to be having some internet issues. Okay, fortunately, we haven't dropped any frames so far. It just seems to be saying that we are having internet issues. Let me let me close some things um, that might be putting a load on the connection. Also, Flynn, hello, hello. Welcome to the stream. Thank you for the follow. Appreciate it. Uh, we are we are doing a study stream today. Well, I mean, we do study streams every day. We are doing a study stream currently, and today we are focusing on animation using Matplotlib. So we're just reading up on how to go about animating graphs and plots and stuff. Okay. Oh, also, there's going to be an ad playing in like 50 seconds, so like close to a minute. There's going to be an ad playing. So what I'm going to do is I think I'm going to start up the ad break right now, and I'll take a little hydration break as well, and I'll see you guys in 30 seconds. Okay, I'm back. Sorry about that. Flynn, yes, I am programming in Python. Matplotlib is a visualization library for Python. We are currently, to answer the question, yeah, we are programming in Python, and we are running this code in Kaggle notebooks because I've found it to be much faster than running it on my own machine. Okay, all right. Where were we? Right. So, we create the func animation object, and then we pass the figure and the animation function. Then we save or show the animation using one of the following methods. Okay. All right. The following table shows a few plotting methods, the artists they return, and some commonly used set methods that update the underlying data. While updating data is the most common operation in animations, you can also update other aspects such as color or text position. Okay. Covering the set methods of all types of artists is beyond the scope of this tutorial, but can be found in their respective documentations. That makes sense. An example of such update methods is use for methods in use for scatter and plot is as follows. Okay, all right. So we're going to be doing a line and a scatter. We'll probably not do this uh all of this like their specific math that they're doing. However, we're gonna try and create our own sort of function for this, or our own kind of animatable thing. Okay, so what's happening here? So uh this we first create the subplot, okay? And then there's this thing. Okay, so this is all data that's going to be plotted here. So then there's the scatter and then line, and then we are explicitly setting the x limit for. Oh, X and Y limit for the axes. And there's also a legend thing. Okay. All right. All right. Then we have update. Now where, okay, so we are passing it in here. Okay, so in update, X equals so and so. How is T accessible within the function? For each frame, update the data stored on the artist. For each frame, update the data stored on the artist. Okay. Then data equals so and so. Then scatter dot set offsets and update the line plot. And then finally, we are returning both the scatter and line. I'm assuming it's the artists. Hold on, dude. How are scatter and line 2 accessible within the function? Usually like within Python, if or within a Python function. So let's say if I have this and then I created a function here, then I try to print out, hold on. Then when I try to print out A, it should give an error, shouldn't it? Wait, that's interesting. Because A is not defined currently in this scope, unless I do something like global A, which I think should. Oh, hold on. I'm not calling the function. I just realized that. Okay, so sum01. How is this working? I've had this issue previously where if I try to, or was that with reading? No, hold on. Was that with setting? I think that might have been with setting values. So for example, if I did, though, I mean, then why if I do this? Yeah, see, that throws an error. It says local variable A reference before assignment. But then this works. Okay, there's something that I'm missing here, that there's something that I'm forgetting. So I'm just gonna ask the the language model. I just came across something in Python that kind of confused me. In the following code, A equals 10, and then def sum01, print A sum01, code. How is the sum01 function able to read A when A hasn't been defined in it? If I tried to increment A from within sum01, it would throw an error. but it's able to print the variable just fine. What's going on? Because I'm confused about this because I remember, and like we saw the error as well, right? Um, so okay, let me just see if that error can be solved using global A. Okay, so this is why I'm confused. It's because usually you would need to add this statement, but that's if you plan on like playing around with the variable. I don't remember what I had read in terms of like not needing to explicitly specify it if you are just reading the variable. Like if you're just reading uh, if you're just reading the outer variable. Okay. In your code snippet, the function sum01 is able to access the variable a even though it is not defined within the function because a is a global variable. Okay, my confusion is why am I able to access it without specifying global? Here's a breakdown to explain why this works and why trying to modify without using special keywords would result in an error. Global variables in Python. A variable defined outside of any function or class, such as a equals 10. Oh, wait, a variable defined outside of any function or class. Okay, that's a global variable. Okay, they were just giving an example. All right, is considered a global variable. By default, Python functions can access global variables, but they cannot modify them directly unless explicitly declared as global within the function. Oh, did I did I not know this, or did I know this and just forget that this was a thing? I'm trying to remember if I've ever read this at some point in the past. I don't think I knew this, that you can access the thing directly. I was assuming that uh, because for modifying it you would need to create that global statement. So probably even for reading, you would need to create that global statement. And okay, now it makes sense why this seems to be working. It's because it's defined outside, and we are not modifying it. Yep, okay, that's true. That is true. We are not modifying it. We are calling functions that modify stuff, but we are not modifying the variables directly. Okay, all right. And this also explains why we are able to access T and Z. Now, hold on. What is So I'm assuming T and Z are supposed to be they're supposed to be arrays, or they're supposed to be arrays of some sort, right? That's why this code is able to access it in this way. And if that's the case, then I'm assuming frame is a number. It's a current frame number. Okay. Um, you know what? We could just copy this entire code and paste it and see the thing in action, but I kind of want to set up my own logic as well. Okay. So there is an error. Oh, saying animation not defined. So in my case, I called animation anim, and it's not displaying the thing here. So let's try that. I forgot what it's called. Cell magic. I don't know if that's gonna work here, but let's see. IPython not defined. Okay, what does this say? Animation was deleted without rendering anything. This is most likely not intended. To prevent deletion, assign the animation to a variable, example anim, that exists until you output the animation using plt.show. Using plt.show or animation.save. Wait, that's kind of confusing. Hold on. I did store it. I stored the result into this variable. What am I missing here? Okay, let's try running it again and see. Now it's just saying IPython is not defined. Okay. Let me see if other people have had a similar issue and if they had to bring in IPython. From ipython.display import HTML. From ipython.display import HTML and then HTML.2.js HTML. That's the JavaScript animation thing. Okay, let's try that. From ipython.display import HTML. And then down here, do we still need to call show? No, in this case, I don't think we need to call show. So then HTML equals Annie dot, no, HTML, we're calling the function, and then Annie.2.js HTML, and then let's run that. Oh, there it is. Okay, holy shit, dude. Okay, I didn't know that it gives these controls. That's actually great. So you also have the option to loop the thing, so you can play the thing from. Oh, that's crazy, dude. Wait, I'm not sure. I'm not sure why it's. Oh, it's because I. Oh, okay. Dude, that is crazy. I didn't know that it does this. I actually don't even know um if the thing, what am I trying to say? If I didn't do this, if I didn't do the JS HTML, if I just did plt.show, I don't know if it would show these controls. And this is great because it allows you to step through it as well. What does zooming do in this case? Oh, no, it's not zooming. It's increasing and decreasing the speed. Holy shit, dude. Yo, I'm glad that I explored this thing as well. And now, I mean, I think I'm just going to be using this. Dude, you know what's interesting? There's various things that I found out like about notebooks that are like kind of available. There's various features that I found out that are kind of available that I didn't know were available. Mostly because like I hadn't had the need to use them, but then when I did need to use them and I looked up, hey, how do I do so and so thing? They were available. For example, playing audio. You're able to play audio through notebooks. Like you have to provide it with the audio data and it plays the audio. And there's multiple different ways that you can provide it with data. Um, that was crazy to me at least. And then there's this display thing. Display itself has like a bunch of different features, and this is all like to do with IPython. Um, dude, that's wild to me. Like I'd been using notebooks for a while before this, But then I didn't really even know what IPython was. And then I looked into IPython and I found out that like it's kind of the tech that powers all of this. And then there's like all of this UI built on top of it. Um, I don't remember the exact details, so I don't want to like accidentally give wrong information. But uh, IPython is the tech that like this stuff is built on, like these notebooks and stuff. And that's one of the reasons why you're able to customize how things are displayed. There are various different. You can actually implement your own display mechanisms as well. The way that you have this HTML thing. I think the audio thing comes under display as well. Give me a second. Let me just look that up. Oh, actually, you know what? Let's get a good explanation. Let's get a good explanation from uh, a language model. Okay, so um, I just found out that um, I can pass a Matplotlib func animation object to the HTML function from IPython. No, wait. I just found out that I can render a Matplotlib animation in Jupyter Notebook by passing the func animation object to ipython.display.html. I'm curious about IPython itself. What is this and how is it connected to Jupyter Notebooks or Jupyter Notebook? Yeah. Also go into, no, also cover the display module. Okay, this is loading. Oh God, I forgot. I'm asking this question to DeepSeek. No, I want a small answer. No, you know what? Okay, we can look at the big answer. Okay, I need to understand what IPython is and how it relates to Jupyter Notebook. The user mentioned using IPython so and so to render a Matplotlib animation, so I should probably start by breaking down IPython first. IPython, I think it's an interactive Python shell. Yep. I remember using it before Jupyter existed. It had features like tab completion and magic commands, but how does it connect to Jupyter? Wait, Jupyter used to be called IPython Notebook, right? So maybe IPython is a kernel that Jupyter uses for Python. Okay, but wait, Jupyter supports multiple languages now, not just Python. So IPython is specifically the Python kernel for Jupyter. So when you run a Python notebook in Jupyter, it's using the IPython kernel. That makes sense. So IPython is a part of the Jupyter ecosystem, but can also be used independently. Wait, so IPython is a part of the Jupyter ecosystem, but can also be used independently. Okay. Now the display module in IPython, the user used HTML from IPython.display The display module must be used for rich media outputs in the notebook, like showing images, video, HTML, or even JavaScript. So when you call HTML, it tells the notebook to render the HTML content instead of just printing it as text. Similarly, there are functions like display.image, display.json, etc. Okay, I didn't know about those two. So how does this integrate with Jupyter? Jupyter provides the notebook interface, and IPython provides the Python backend. The display module is part of IPython's tools to interact with the front end, which is the notebook, enabling rich displays. That explains why passing the func animation to HTML works. It converts the animation to an HTML5 video or something that the notebook can display. But wait, func animation is from Matplotlib. Matplotlib has different backends. In a Jupyter notebook, using Matplotlib inline would show static images, but maybe using a different backend or using the notebook backend allows interactive plots. However, rendering an animation as HTML would require converting the animation frames into a format that the browser can display, like a JavaScript animation or embedded video. The ipython.display.html function probably takes the animation's saved HTML representation. I just realized that when I said that I was passing in the func animation object, I wasn't actually passing in the func animation object itself. I was passing in Annie dot to JS HTML or whatever that function was. So there is some kind of conversion happening there, and then whatever object is being returned by that function, that is what I'm passing into HTML. I just realized my mistake in the question. Okay. So it takes that saved HTML representation and injects it into the notebook output cell. So putting it all together, IPython is the interactive Python kernel that Jupyter uses. The display module in IPython offers functions to render various media types in the front end, which is the Jupyter Notebook interface. This allows outputs beyond plain text, enhancing the interactivity and visual appeal of the notebook. I should keep ipython.display in mind for the future, just in case I need to render various things. Because in my mind, it would be like, okay, I want to render this image. So I have a couple of options. I could save it. I could save the image in the notebook's storage, and then create a markdown cell. And then in the markdown cell, I can access this image, right? And then display it in that way. Another way that would come to mind is displaying it using PIL or displaying it using Matplotlib. But then if I'm able to just do it this way, then, why not? Okay, I should also mention that Jupyter's name comes from combining Julia, Python, and R. I did not know that. I did not know that. Okay, but now it supports many languages. However, the original IPython notebook became Jupyter, and IPython remains the Python kernel. The display module is part of IPython's features to handle rich media, which Jupyter utilizes in the user interface. Another point, the display module can detect when it's running in a notebook environment and automatically render certain outputs. But using functions like HTML gives more control. For example, in the case of animations, using HTML might be necessary to ensure the animation is rendered correctly instead of a static image or a plot that's not updating. Also, the display module can be used to display other formats like so-and-so, so-and-so, so-and-so. Okay, audio is also a part of that, okay? It's a versatile tool for creating dynamic and interactive content in Jupyter Notebooks. So when you use ipython.display.html, you're essentially telling Jupyter to interpret the output as HTML, which the browser then renders. Okay, all right. Okay, so this this has gone on a little longer than I expected it to go, which that's cool. But here's what we're going to do. So I'd mentioned earlier that I wanted to do at least, an hour stream. Um, yeah, yeah. I wanted to stream for at least an hour. I wish I could go for a little longer, but it's a little past the time when I'm able to do talking streams. So here's what we're gonna do. Okay. So I don't know. Yeah, I think this person might still be. Yeah, they're probably still live. Okay. Okay. So we're gonna raid this person called Blue Enfield. Yeah, we're gonna raid this person called Blue Enfield. They are. I'm not sure what they're studying. It says pre-foo blue productivity. So I don't know what they are studying. Um, but yeah, we're gonna go raid this person. Okay. All right. I'm gonna carry on reading up on this animation thing. Um, and hopefully I'll finish the animation thing, and then we can get back to doing our neural network studies. I've also started reading up on convolutional neural networks because that's the next thing that we're going to be jumping to after we finish fully learning how to train a feed-forward neural network. And of course, there's a bunch of the experimentation that I want to do as well with feed-forward neural networks. But like that's going to be alongside learning about convolutional neural networks. I wanted to start learning the theory of it first. And I mean, now I can also go back to that MIT video, which was explaining convolutional neural networks. But yeah, that's going to be it for today's stream. I'm going to try and start my stream a little earlier tomorrow so that I can, you know, stream a little longer. Let's see how that goes. Uh, Flynn, thank you for the follow and thanks for hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. Um, yeah, yeah. That being said, I hope you guys have a nice day, and I'll see you all next time. Peace.